So this is another orbit problem. Chances are we're going to be dealing with Kepler's laws because those are the ones that tend to give us really nice, easy answers. And it says that a planet is traveling in an elliptical orbit around a star as shown. What pair of points is the speed of the planet the same? Well, I know if it's going around the planet, that I'm going to have my planet either at one of these two locations. And I know that if it's going around one of them, that really this is kind of a symmetric case. I can kind of reason out that if I put it at one, everything to either side has to be kind of similar. So let's look at our points. If I put the sun here, either of them would be a reasonable one. It would just reverse all of our values. But if I put the sun here, I know that this is the slowest because it's the furthest away. So if it's the furthest away, it's going to have the least amount of force, which means in order for it to actually gain back, this is its kind of turnaround point. W is its fastest point. So I know that W and S cannot be the same because of sweeping out equal area in equal time. So if I look at that area there, my values are going to get closer and closer together as I get around to the outside. This triangle gets longer, which means its base has to get smaller. When I'm close to it, I have a very short distance, which means my equal time means I travel in a really long distance. So that's my justification for my fastest and slowest. I'm actually looking at the Kepler's second law of equal time in equal area. All right, I look at P and T. Well, they're opposites of each other, but if I look at here, it's really close to the sun over here. This planet is really close to the sun, so it's going to be going really fast to sweep out that area. Over here, this distance is much further away, so it will actually be moving slower over here to sweep out the same area as it does on the other side. So P and T can't be at the same spot because of equal time in equal area. Same thing with P and R. P and R are going to be sweeping off the same area in the same amount of time, but R is further away than P is. So P has to be going at a faster rate. Q and U are exactly opposite of each other. We would look at the triangles that they would sweep out, and they're going to sweep out the same area in the same time. And since they're the same distance away, they're going to be moving at the same value. So I think D is my right answer. Just want to check V and R. V and R is exactly opposite of P and T, so that one cancels as well. Really what it comes down to is P and V are at the same speed. Q and U are at the same speed, and T and R are at the same speed. So any of those three pairs would have been correct.